This meeting is recorded. Welcome everyone to another Open Cluster Management Community meeting. It is September 30th, 2022. Today we have two topics. The first one being Zhenhua Yang is going to present the placement spread policy proposal, and then later on Nitish gonna do a POC on the OpenTelemetry add-on. So first up, Zhenhua, please take it away. Thank you.
Okay. Could you hear?
Yes, we can.
Oh, yes. Now I will start. Today I want to demonstrate the spread policy in the placement operator. For the demonstration, I have 9 clusters in total, and they are organized in a hierarchical structure. And the first 4 clusters are provided by the provided GCP, and the remaining 5 clusters are provided by the provided AWS. For the clusters provided by the GCP, they are organized into two regions. The first 3 clusters are in the region Asia East, and the cluster 4 are in the region Asia South. For the clusters provided by AWS, they are also organized in 2 regions. Cluster 5 to cluster 7 are in the region US East, and cluster 8 to cluster 9 are in the region US West. Now I will pin this figure in my screen for convenience. For the demonstration, my modified version of the placement operator is running locally in my laptop connected to the remote Kubernetes cluster. And all my operations are performed in this VS Code session. The VS Code session is a remote SSH session, which is also connected to the machine running my Kubernetes environment. Now let's start it. So first, let's look at the clusters. In order to organize these clusters in a hierarchical structure, we have labels in them. For example, for cluster 1, we have a provider GCP label and region Asia East label. Users that have different structure of the clusters may have different labels. For example, they may have a zone label or an environment label, such as testing or production. Now I will apply these clusters to my environment along with managed cluster set and cluster set binding. Both of them are named as demo. Or we can see that all the clusters have been applied. Now let's begin with placement. The placement object is the input of the placement operator, which tells the scheduler, the OCM placement operator, how to select the clusters. The placement P0 is the basic one that is already supported by the placement operator. In the spec, we can see 2 fields. The number of clusters tells the scheduler to select in total two clusters, and the predicts. In the predicts, we have a label selector that tells the scheduler to select only clusters that are provided by AWS. Let's now apply the P0 and see what will happen. we can now see a placement decision of the placement P0, and by getting it, we can see the which clusters are selected. Now we can see that the cluster 5 and the cluster 6 are selected. Both of them are from the provided AWS and the region US East. Now let's consider a scenario that sometimes we want to select the clusters from the two different regions. One cluster from the US East and one cluster from the US West to achieve maybe disaster tolerance or cross-region load balancing. So this feature is today's topic, the spread policy. Let's now switch to the second placement object, the P1. In the P1, we have the same number of clusters and the predicts field as P0, but now we have two more fields, the spread policy and the prioritized policy. In the spread policy, we have a spread constraint. The spread constraint tells the scheduler to spread the workload to the regions so that the scheduler will select one cluster, one cluster each region, and the prioritized policy give the spread code a weight. Although the spread policy is not implemented in a prioritizer, it contains a prioritizer-like logic that will score the clusters. Finally, the scheduler needed to have a weighted sum of the score from the spread policy code and the scores from the other prioritizers. So here we need a weight. The weight by default, the weight of the spread policy is 0, which means it is disabled. Now let's apply the object P1 to see the placement decision. Now here is a placement decision. We can see that after adding the spread policy, the two clusters are from clusters 5 are from US East and cluster 8 are from US West. We then achieve the spread across the regions. We can also change the number of clusters to something like 4. Then there will be 2 clusters in US East and two clusters in US West. Let's wait a minute. Now we can see the schedule. The placement decision contains 2 clusters from US East and 2 clusters from US West. Now let's switch to another placement object, P2. in P2, we change the label selector in predicates that from AWS to GCP. That means we for the placement P2, we want to select the clusters in the provided GCP, and we want in total 4 clusters. Let's apply the P2. Now, the placement decision of the P2 contains 3 clusters from Asia East and only one cluster from Asia South. This is not even spread. So for the provided GCP, we and the number of clusters 4, we cannot get even spread due to the cluster number limit in the region Asia South. By default, the spread policy do a best effort spread. So if we want to change this best effort behavior to strict behavior, that if the skew exceed some threshold, we may want the scheduler to report an error. We can add the max skew field in one specific spread constraint. For example, the max skew 1 means that the skew means that for this example, the skew is 3 minus 1 and is 2, which exceed the max skew constraint. So let's apply the new P2 and see what will happen. Now we have applied the new P2. And now the P2 decision is not found. Let's check the placement P2. The placement P2 say no managed cluster matched. Let's get more information. In the conditions, we can see it reports that the max skew on region cannot be satisfied. Now let's switch to the last placement object, the P3. In P3, we comment out the predicts, which means we want to select the clusters from all the 2 providers, and we add a new spread constraint on the spread policy that tell the scheduler to spread the workload to the providers. Now we have 2 spread constraints in total, and each of them have a weight. The weight here indicates the order of the spread constraint. For example, in this placement object, we should the scheduler should first do the spread according to the provider, and then in each provider, the scheduler will do the spread according to the region. So let's now apply the P3 and see what will happen. from the placement decision, we can see that since we only want 2 clusters, and 1 cluster is in the provider GCP, and 1 cluster is in the provider AWS. Now we can change the number of clusters to 4, and we will see there will be 1 cluster in there will be 2 clusters in each provider, and there will be 1 cluster in each region. And the placement decision contains exactly what I have said. For this example, we have the spread constraint can also contain a MaxQ field. Now we can change the number of clusters to 8, and the things and now the since the skewness of the in the provider GCP exceeded the max skew limit 1, and we expect the schedule will be filled. And the message report that the max skew on region cannot be satisfied. Now here are all I want to demonstrate today. Thank you.
Thank you, Zhenhua. Are there any questions? That was a great presentation, first of all. Thank you so much for the demo and the enhancement proposal. Are there any questions for Zhenhua regarding the spread policy? Q-Jen?
Oh no, I think it's a great demo. I like the way that it sets a spread policy. I have some question like, for example, I'm still not quite sure whether when it is a hard, I mean, it's a best effort. Yeah, so when it's a hard constraint, like when we set max skew, do we need to set a prioritizer policy? I mean, it seems to me that we could set a prioritizer policy if there is a spread policy, but it is not necessary. It is not necessary at the first step. So yeah, maybe we can talk offline on that. My suggestion is that for the better user experience, maybe we could set spread policy, and then under the code, we by default give it the prioritizer weight if user doesn't set it.
This means we should set a default weight.
Yes, I think
okay.
As long as that spread policy is not empty, we probably could set a default weight, but user can still change it.
We can talk later offline.
Yeah, but yeah, this is really great. Thank you.
Any other comment for Zhenghua? Li Yang, do you have any feedback?
I think this this demo is very is awesome, and it has already implemented what we want originally. I have a question about the max skill. Once user specifies the max skill, and if we cannot find the desired number of cluster, will the scheduler return failed, or it will try its best to find some clusters? I think we can discuss this offline. Anyway, this demo is great. Thank you,
Okay.
Zhenghua.
Thank you, Li Yang, for the feedback. If there are no more questions, let's give it another second. Okay, if there are no more questions, Nitish, do you want to show your presentation regarding the OpenTelemetry add-on? Thank you.
So is my screen visible?
Yes, we can see your screen.
So this presentation is about how we can introduce the distributed tracing in the open cluster management components. So this is a project that I worked on as an OSPB 2022-20 under the mentorship of Milky. So these are the topics that I will be covering today. These topics are like, first of all, I will be covering the add-on, then the tracing part of the add-on is a supplementary, you can say, and like a supporting feature to the tracing, and then we can have the demo in the last. So let me start with the add-on. So this is the add-on structure that is developed by now. So the add-on structure, this add-on is developed on the add-on framework that we have in the OCM. So the add-on, the add-on starts from the add-on manager, which will be responsible for deploying the hub components as well as dispatching the collector agents via the add-on framework. So what it does, like, first of all, the add-on manager installs, then it deploys, then it triggers the deployment of these two components, the OTL collector and the Jagger all-in-one. So this Jagger all-in-one is the like a combination of all the components of Jagger, like collector, query for the front end, and also the storage. So that user can query this and get the traces out of the that it is collected. The OTL collector will be responsible for collecting the traces from the OCM components through the in-cluster service that it will provide. The OTL collector will provide two ports, like at 4317 and 4318. At 4317, we can have the gRPC connection, and at 4318, we can have the HTTP connection. So now, as this is a hub and spoke architecture, so as this add-on manager will like dispatch the agents. So the dispatch agent will be installed in the managed cluster as well as a deployment, and their deployment will like that pod will contain two containers. One of the container will be an OTL collector, which will be responsible, like which will have the same task as the collector in the hub one. The only difference will be it will be exporting the traces from the managed to the hub one through an service. We have a node port service for now, and the collector agent will also be having a one more container which will be responsible for updating these leads. Similarly, as in the hub one and the managed one, we also have an infrastructure service which is responsible for collecting the traces from the managed cluster components, from the like a clusterlet and the registration element and various other components that we will be having in the managed cluster. So this is the add-on structure for now. And let me move forward. So we can install the add-on by installing directly from the help chart, and we can verify this add-on installation in the open cluster management add-on namespace by getting all of the ports from this namespace. So we will be getting these three ports in the open cluster management add-on namespace. So now let me go to the second part. The second part is about tracing. So normally what we do is like tracing is basically categorized in two parts. So there is in-process tracing and an inter-process tracing. So the idea behind the in-process tracing is that we have a single service, and in a single service there are multiple processes. So that for example, like in the OCM we have like a main controller, and the main controller is using like different functions. So like the controller starts from the sync function, and we have different functionalities that is called by the sync function. So this is in process propagation, where we can pass the we can propagate the context between the processes. And when we do this the same thing between the microservices, then we have the inter-process propagation. So an example or like an implementation of in-process propagation will be something like this. So assume these four functions, and assume the function A as the root function. So like all the implementation starts from the function A. So OTL provides us library and API functionalities that we can use to start the trace to start the span. So here what I'm doing is we are initializing, like we are naming a tracer with a name, any name we can want, and then we start the span. So when we start the span, it accepts two parameters, the context and the span name. So just like assume it as its name, it is named as A. So this the what a OTL checks is it checks the context, and if that context is exported from any previous function, and that previous function have some span, then it links this span as a child span of that previous span. So like so that the previous span will be a parent one, and this one will be a child one. So and this span will be ending as soon as this function is closing by the defer statement. Now what we're doing is that is as the function A is called, and it is becomes it is now the root one. Now we are calling the function B and C and passing the same context that we have used in the function A. Now as we pass the same context in the function B, what will happen is in function B, when it checks the context already contains a link to the previous span. So what happens is it will build a new span B, but the new span B will have a parent as a span 1. So it will be a child 1. So the relationship will be something like this: A will be the parent and B will be the child. Similarly, in function C will be the child of A, and D is the subchild of, like a child of D, which is also a child of C, which is also a child of A. So the final trace will be looking something like this. The trace is started from the function A, and like a trace starts off. This is the complete trace, and this is the parent span, like root parent span, and then B is a child of this, and like this. So this will be the output of this. Now in context of open cluster management, so like this is an example of a cluster manager controller from the cluster manager. This is our trace timeline which we'll be getting. As you see, there are like same names apply deployment for like multiple times. This is because we are naming the span as a we're naming the span as the function names, and these functions are called multiple times for different resources. So a trace graph of this will be something will be look something like this. The cluster manager control will be calling these are the functions that this is cluster manager is calling, and the like these functions are also calling some other functions, and these are the functions. So what does trace graph does is it also groups the spans which have the same name. So like the apply deployment span which we are seeing in the previous trace timeline screen, they all will be grouped together in the form here. And we can see details about this span about this trace as well, like total span set, like the total span set, it is having the 14 spans, and the depth, and it is it is available in only one service. So like this trace is exporting from a single service. So now the inter-process propagation. So the idea behind inter-process propagation is same as we have in the HTTP request. So what we do, like what happens in the distributed tracing in HTTP request is like there, like assume there is a receiver and a sender. So like when a sender sends some traces, send some request to another receiver. So what we do is we inject the traces into the HTTP header, and then the receiver extracts that traces and builds a span to that sender. So the idea is same here as well. Instead of HTTP request, what we can have is we have Kubernetes object. So what we can do is we add the traces as the annotations in the Kubernetes object. So we have these four functions that we can use now, and these two are the main function: trace to object and span from object. So the trace to object function, it accepts two parameter, a context and a runtime object. So what it will be doing is it will extract the span from this context and it will be adding that that trace span under the prefix name of trace.ocm.io/trace parent in the annotations of Kubernetes object that we are reconciling or editing or updating anything. And this trace to annotation function is an helper function to this trace to object function, and we can also call it directly, because like sometimes we need sometimes we can't pass the runtime object directly, but we can pass the annotation. So it will be accepting the annotations in a and the annotations, and the user can manually set the annotations itself and update the object after setting the annotations. Similarly, the span from object function, it accepts four parameters: the context, the name of the tracer we want to give, and the span name and the runtime object. What it does is it will check the runtime object. If there is an span in the annotations of this runtime object, it will build a span making that annotation trace as the parent span. Otherwise, it will build a new span taking the context that we are provided as the root span. And the span from annotation is also the same as the trace to annotation. It is a helper function to span from object. Span from object. And this is span from object, like span from annotation. There is only one difference in the parameter. It accepts the annotation instead of runtime dot object. So in context of OCM, it will be looking something like this. This is an example of an CSR controller. What it does is, if there is a new CSR, if there is a new CSR generated from the registration spoke, is here referring the registration agent in the spoke cluster. And if there is new CSR approving, new CSR generated, the CSR approving controller in the registration hub reconciles that CSR and authorize it. So these two spans get linked here. So in the trace graph form, it will be something like this. So the client certificate controller, it syncs the CSR and generates a new CSR. It will inject the trace annotations into that, and the approving controller will reconcile it and then authorize it. And this the CSR and this another span is just checking the CSR whether it is in a terminal state and other functionalities that is approving controller have. So these are in a different color. So what Jagger does is it shows services or spans from different services in a different colors. So these are from two different services. You can see two different services. One is registration spoke and one is registration hub. So now let me show you the demo. So this is a local kind cluster that is up and running now. So this is a kind cluster that is up now, and this kind cluster is up from this bash script. This bash script is available in the OCM repo, in the OCM GitHub repo, and only change is that I'm using the registration the different images, because the OCM one it doesn't contain tracing by now, and this repo contains the tracing. So if I show you the clips here. So this is an hub spoke architecture. It contains this is the hub one and this is a managed cluster. The cluster is true now, and now let me install the add-on by now. So to install the add-on, I'm using this hand chart. So what it does is so this hand chart will trigger the installation of the add-on manager, which will be responsible for the triggering of the other two functionalities, two other ports of a Jagger collector and the OTL collector. So these two ports are creating now from this manager. So let them up. It nearly takes like 30 seconds. And let me show you the managed list as well. So this is the managed cluster. It is also trigger the collector agent, which is an token trigger port, and it is also upping. Now the Jagger element from the hub is up. So let this also few seconds. Yeah, this is also, now we can see the add-on. So this add-on is available now. Now we can see the traces. So for the traces, we have to, like, for now we have to expose port forward the Jagger all-in-one from the port 16886. So at that port, Jagger query is available. So now the port is forwarding at so it will query the localhost. So like the idea is, as we have different components, we name it from as a different services. So these two are up now, and we have the tracing is available in those four components in the cluster manager, in the registration controller, and in the managed one in the cluster led and the cluster led registration engine for now. So if we search the traces, so these are the traces that are exporting from the lease controller in the registration number, and these are from the registration spoke. So like if you see any of the traces, just a second. So it is up now. So the traces from the registration number and the spot. So also like if you see any of the traces just like this. So this is the tracing that you are getting from the registration spoke, and these are the functions that we getting from the Jagger lab: trace timeline, trace graph, and statics flame graph. Like there are many, so don't know very much about them. And we can also do these like the operations. It provides operations here, and from these operations we can select a specific operation we want to search. So like these operations are just the expense name that we have given to the different functions. So like if I so like the check how many times this function, so this function is available in this one, and we can see the traces as well. So like the cluster manager is also up by now, and we can select, and we can see the cluster manager as well. So like this is the cluster manager example that I have shown you in the from the in process propagation. So now let now let me show you the how we can avail the to show the functionality of inter-process propagation. So what I will be doing is, so to generate a new CSR, what I will be doing is I will be editing one of the secrets, and the secrets will be the controller will be generating the new CSR after as the secret is changed. So now let me edit the TLS, delete the TLS cert key here. So what it will be doing is a new secret will be generated, a secret will be edited and a new CSR will be generating, and that CSR will be collected by the registration hub. And so the registration hub, these spans will be get linked together. So the CSR and the new CSR generated, and the CSR approval control check the CSR and finally authorize it. So in the trace graph form, it will be looking something like this. Like we have two services here, not these spans are generating from two services. And these are the functions, operations we can have. So this is for the demo part. Now there are there can be future improvements as well. the add-on for now, like it is using port forward services to expose the Jagger to collect to see the traces in a nearby time. We can have some front end services to expose that Jagger front end, and for the add-on as well. The configurations are like some there is no single point of control for the configuration by now. In the future, we can have a CRD on top of everything, like the single source of configuration where we can edit all the configurations, and as well as like for the securing the connection between the collector from like in the in different managed cluster, we can have some certificate rotation mechanisms. Both the OTL collector and the Jagger one support the TLS certification. And for the tracing part, so like these tracing parts have been tried on the registration one and the registration operator. So these can be extended to other parts as well. And tracing can also be improved. Like right now, we are just naming the functions like the spans are collecting as the function name. We can have events and the error logging in the spans as well. And like these are like very beneficial. So like now we do not know like from where the function returns, but now we can add events in that. So like when the function returns, it adds an event to this trace. So this is all from my side, and thank you for giving me the time.
Thank you, Nitish. That was a really great demo with a lot of details. Kijang, do you have any feedback?
Yeah, I have some questions. So the first question is, so when we do the in-process and the inter-process tracing, so I think we need to inject the code into the existing component.
We can have there is a tracing package. I have code on the fork of registration on my on my GitHub for now. What it does is we can have a thread as a thread or a controller. So like the code that is present right now on the registration one, it is using two controllers. So like for the hub one, controller which is pointed to the informer of cluster management add-on. Managed cluster add-on. So a cluster management add-on. So if it checks like after at a certain interval, if the add-on is up, then it initializes the tracer, and after the initialization of the tracer, we can have to do this part that you have asked manually. Like we have to when do we have to inject the annotations or annotations into the object, and like when we are updating the object, before that we have to inject it from the functions that I have mentioned here. Like for the interprocess and for the process propagation, we have to do it something like this.
So if we talk about a new, for example, if we have a new workload, like a new service that intends to use this kind of tracing, is there any additional configuration? Does it just need to start the service like there are applications on the spoke and then inject some tracing code into that? Is that enough, or is there any other configuration it need to do?
No, there will not there are no other configuration. Just we have to do the tracing part, like inject these functions. Where do we have to have the tracing? Another part the in-cluster service is available to all the components, so the traces will be collected from all of them.
Yeah, let me add a little bit more about this, because regarding Chujan's question about introducing the OpenTelemetry tracings into trivial applications, actually there's kind of a implicit dependencies in the whole OpenTelemetry framework, which is the add-on is relying on a multi-cluster network framework. Currently, for example, we need to when we are pushing some OpenTelemetry metrics or traces from the managed cluster to the hub cluster, we need to we need to have the connectability. So however, in the demo, where it is working because we have the node ports. We are exporting the OpenTelemetry services, the Java services.
So sure. They are kind of in the same VPC.
Okay. So
like-
somehow if there is an arbitrary service, we also need to like maybe a configuration that need to
Yeah, we can have it like on the when we initial when we install the add-on. So like if they are like the managed cluster and the hub cluster are in like different regions and they are not directly connected, we do need to have some configurations. That part is correct.
Okay. Yeah. Thank you.
There's also some hacking we're supposed to do, like to introduce to the applications. No, quote unquote hackings, because it's de facto standards for now. I'm not really sure. The open telemetry libraries, and we kind of for now we hacked we forked the registration components in the open OCM and hacked some tracer. And the span code into the repo. Yeah, but it's a standard. It's following some common specifications. So I'm not. I think maybe in the future we can introduce that in the core components.
Yeah.
Maybe after the add-ons getting more mature.
Yeah, after that one mature, we can have it in the other services as well, like other components, and we can do for now the inter-process propagations, we are only introduced it in the CSR controllers, so only in the CSR process. So there are other processes as well which reconciles a single instance. We can also introduce with them as well when it gets more mature.
Is there any yeah, I think this is interesting. I'd like to know more about that. Is there any document or yeah, maybe I can check the code and see how it goes.
Yeah, I was right. Yeah, I was about to mention about that because my apologies, I forgot to add it to the agenda because we a few days ago we opened an issue for requesting a new repo and there's a new issue in the community repo of OCM under OCM organizations. And if we can have a new repo for that, and then we can kind of have a playbook, have a reproduced document in the README of the new repo, or some folders under the new repo, so that future visitors can easily reproduce that in the local environment.
Yeah. Yeah, I'm fine with that. I think it's fine to create a repo for this project. Or, I mean, I'm not sure. Mac, do you have any opinion? Or we should have a staging repo. Just put maybe multiple different add-ons in that.
Yeah, I think we should. It'll be a good way to show that there's some progress going on with these staging add-ons, but also have a place to hold them. Yep, I agree.
Cool. Okay.
Let's talk soon.
Thank you, Nitish, for that great demo and presentation. Are there any other questions for Nitish? If not, Qicheng, do you want to mention anything else?
No, I think these two demos are both great. Thanks for your work. It sounds really nice. It looks nice to me. Thank you.
Anyone else? Any final words? Well, thank you again, Zhenhua and Nitish and everyone.
Thank you so much.
Take care. Have a nice day. Bye.
Thank you. Bye.